Okay, so some of the elements in the periodic table of metals, the electron configuration is this 283. Which row shows the group and the period where this metal is found? So if you remember, the period is the number of energy levels. So there's 1, 2, 3 energy levels. So it's got to be in the third period. And then the fact there are 3 electrons in the outer energy level means that this is the group number. So this one is group 3, period 3. Okay, lithium are alkali metals and potassium rubidium. Describe what you see when a piece of rubidium is dropped into water. So if you remember, these metals are all going to react in similar ways, and you will have seen lithium and potassium in class. So what you would get is the metal will start to bubble. You get bubbles forming. You would get a flame produced because as they get more reactive, they're able to ignite the gas that is being produced. You've only got to get 2, so that's probably 1 there and 1 there. There are other things you could have said. It gets smaller. It would float around on the surface and move quickly on the surface. Right, we've got the electron configuration here of lithium and potassium. Lithium is less reactive. Explain in terms of electron configurations why lithium is less reactive than potassium. Okay, so what we've got to remember here is both these two are trying to lose their outer electrons. So both are trying to lose their outer electrons. In lithium, the electron is closer. It's only in the second energy level. As you can see, it's in the second energy level here. So it's closer to the nucleus. So there is greater attraction for that energy level, for that electron, sorry, and therefore it's going to be harder to lose. You've also got the idea of this one also has less shielding because it's in the second energy level, where this one here has got 1, 2, 3 energy levels shielding this electron. So that's going to be held in a more weakly, and the fact it's further away again makes it easy to lose. So let's put that into words. So why is lithium less reactive? So we're going to say that in lithium, the outer electron is closer to the nucleus. There is also less shielding, and then this means the force of attraction for the electron is greater, so it is harder to lose. So it is harder to lose, and therefore less reactive. Okay, there's 3 marks, or less reactive. There's 3 marks, so going to get 1 in there, 1 in there, and then 1 here for the points. Okay, carrying on. Lithium's got isotopes. We're told here the percentage abundance and the mass of the isotope. Calculate the relative atomic mass. So we're going to find the relative atomic mass. And to do that, all we do is we do 7.59%, which means out of 100, and times it by 6. And then we add it to 92.41 out of 100 times by the 7. Okay, so let me just do that on my calculator. Turn it on. So we've got 7.59 times 6, and then we've got to divide that by 100, and then we're going to add 92.41 92.41 times by the 7 and divided by 100 also, and that's giving me an answer here of 6.9241. I'm just writing all the numbers from the calculator because I noticed this question says give your answer to 2 decimal places. So there's the first decimal place, there's the second, and there's the third. So the third decimal number is a 4, so I don't need to change any of the previous numbers, so it's just going to be 6.92 as a final answer. Remember, this answer should be in between these two numbers, which it is, and it should be nearer to the 7 because you've got 92% of the atoms have a mass of 7. Marks wise, what they're going to give you here is 1 mark for doing this bit, 1 mark for doing this bit, 1 mark for getting that, and then 1 mark for giving the answer to the correct number of decimal places.